Hello guys, welcome to Numerical Point, and this is OQD number 6 and subject is fluid mechanics and topic is capillarity, question level EG, question number 1. And before we start, just hit the subscribe button, press the bell icon and never miss any update. Thank you. Let's get started. So guys, the question reads like, find the capillary rise in a tube of a dia 20 mm when immersed in a liquid of density 1000 kg per meter cube and have a surface tension of 0.02 Newton. Okay, so the dia is given, that is 0.020 meter. Okay, and density is given of liquid, that is 1000 kg per meter cube, and surface tension sigma is given, that is, okay, this is Newton per meter, printing mistake, 0.02 Newton per meter. So the questioner asked the capillary rise. Okay, let's suppose capillary rise is H. So let's don't put a direct formula in this question. Let's first derive that formula, then by the help of that formula we'll uh, find the answer. Okay, so guys, this is our glass tube. Okay, this is our glass tube, and this is the container, and this is the liquid. Okay, so first thing first, this height, okay, this height from the surface to the liquid layer, okay, liquid surface in the tube and liquid surface in the container, this height difference is only called H, that is capillary rise. Okay, and why capillary action takes place? Due to adhesive forces, adhesive forces between the glass and the liquid. Okay, due to this surface tension force acts, and this is happen that the capillary rise takes place. Okay, so first let's denote what are the types of forces that acts in this section. Okay, in this section, in this section of liquid which is in the rise region, what are the types of forces that acts on it? So guys, the first force that will act is the weight. Okay, weight will act downward, and let's suppose the weight is W. Okay, weight will act downward. And what are the other forces that will act? Other is surface tension force at the surface. Okay, so guys, this is the surface tension force. I have shown in 2 points, but it will act in the entire periphery. Okay, entire periphery of the tube. Okay, this is the surface tension force. And the important thing here, we need to know that this angle, okay, this angle, the angle made by the surface, okay, the tangent at the meeting point, okay, the tangent to the surface at the meeting point towards the liquid, okay, towards the liquid will be the angle of contact. Okay, this is the angle of contact. Let's suppose this is theta. Okay, this is height is H, this angle of contact is theta, and it is W. Okay, and this is the surface tension force. So one thing we could say that this surface tension force will have two components. One component, okay, it will have two components. One component will be in the horizontal direction. Okay, one component in the horizontal direction, and the other component will be in the vertical direction. Okay, so this horizontal component will act on the periphery, and it will like, for suppose I am showing here, if you see the top view for the horizontal forces, let's suppose this is the top view of the tube that will be circular, then the horizontal forces will act like this. Okay, so it will act in the entire periphery and equal in magnitude, so they cancel out each other. Okay, the net resultant horizontal force for surface tension will be 0. Okay, the only component that will come into action, that is this vertical component. Okay, so in order to make this fluid in equilibrium, okay, in order to make this fluid in equilibrium, this vertical component of the surface tension force, or this vertical component of the surface tension force will balance this weight, then only the fluid will be in equilibrium. Okay, so now let's balance the vertical component of the surface tension force with the weight. So from our analysis we can write here, okay, we can write the vertical component of surface tension force will be equal to weight. This is our observation from this. Okay, the vertical component of the surface tension force will be equal to the weight, then only it will balance out each other. So now let's balance them. Okay, this is the angle theta, then this will be also the angle theta. Okay, this angle will also be theta, because this is parallel to, this is in the line of this, the vertical component, and this tangent is in the line of this. Okay, so if this angle is theta, then this angle will also be theta. So from here we can write the, what we can write, Fs vertical will be Fs cos theta. Here you can say na, this is Fs, this is Fs, this angle is theta, and this will be Fs cos theta or not, Fsb, this is Fs cos theta, that only we have written here. Okay, now let's put that in our original equation. So Fsb will be Fs cos theta will be equal to weight. Okay, so what will Fs? Fs will be surface tension force. Okay, surface tension force will be surface tension into the perimeter. Okay, what will be the perimeter of the tube of diameter d? That is pi d, and cos theta is there already, will be equal to the weight. What will be the weight? Weight is the of the liquid. Okay, weight of the liquid. Weight of the liquid will be mass into gravity. What is mass? Mass is density into volume. So we can write density of liquid, okay, into volume of the liquid will be, what we can write for the volume? For volume we can write pi by 4 d square, this is the cross sectional area, into height, okay, into what, g. Okay, this is the mass, and into g, then we will get the weight. So now let's cancel some terms from left and right hand side. Okay, so d will go on with 1d, and pi will go, and nothing else. Okay, so we need to find out the value of h. Let's put h in the right hand side and put all the values in the left hand side. Okay, and reverse of that, so that we can get h in the left hand side. So h in the left hand side will be equal to, okay, 1 is sigma, 4 will come here, cos theta divided by rho, this g, and this T. So guys, here we have our formula for capillary rise. Okay, this is a formula for capillary rise. Guys, in the question the dia is given, okay, the rho is given, the sigma is given. So let's put all this value into the formula and find the capillary rise. Okay, so from here, for the value of h, we can write 4 into sigma at 0.02 into cos theta by rho is 1000 and g is 9.81 and d is 0.02. Okay, if the value of cos theta is not given in the question, then take theta equal to 0. So cos theta, let's suppose theta equal to 0. If not given, then take theta equal to 0. If cos theta is not given, so cos theta will be cos 0, that is 1. So this is our value of h. From the calculation we can get h is 0.0004 meter, okay, which can also be written 0.4 mm. So this is the answer for today's question. The capillary rise will be 0.4 mm. So guys, hope you have enjoyed the video. Let's meet in the next video.